Hi, welcome to my video on how to find the instantaneous rate of change. Instantaneous rate of change is the slope of the tangent at a point, which is the slope of the curve at that point. So the instantaneous rate of change is the slope of the tangent at a point, which is also the slope of the curve. So to find the slope of a curve at any point, you're finding the slope of the tangent, which is the same as finding the instantaneous rate of change. And the average rate of change is the slope of the secant between 2 points. So when we say find the rate of change between two values of x, we're finding the average rate of change. When we're trying to find the rate of change at a point, we are finding the instantaneous rate of change, which is the slope of the tangent. So to find the instantaneous rate of change of any function for a value of x, we find another value of x, and I'm going to use 3 decimal places close to x, and find the slope between these points. So instantaneous rate of change is finding the values of the point with two values of x very close to each other, and we'll work out the slope. Here we go. Slope, instantaneous rate of change at, we're going to get the close value, and then we're going to work out the slope. So we got y equals x squared, and we're looking at 3. So a close value would be 3 add on 0.001. So that's 3.001. I'm adding it on. I could also subtract, but I prefer to add it on. So that's the value. So I'm going to find the slope between these 2 points. So if we have a 3, then we take the 3 and square it. So that's y equals 3 squared. So that's a 9. So that's 3 comma 9. Now we got this value. So at this point, we have y equals x squared, which is 3.001 squared. So that value, when we square that out, we're going to get 9.006001. So this point is 3.001, 9 decimal, and I do this because I'll work at the slope from this point. So the slope, which is the instantaneous rate of change, so that's the slope of the tangent to this curve at 3. So the instantaneous rate of change is the slope of the tangent. So the slope is y2, which is 9.006001 minus y1, which is 9, over x2, which is 3.001 minus x1, which is 3. So that gives us, if we subtract 9 from that, again I use my calculator, and 3 from that. So notice I worked out the numerator, worked out the numerator, now I divide. Dividing here, move 3 places, I get 6.001. So that's the instantaneous rate of change at 3. And again, this is an approximation for the slope of the tangent, 6.001. Now let's use another parabola. I'm using the parabolas here because they're easy to work with rather than work with cubics or quartics and other functions. I could do exponentials, but I'm using the parabola as an illustration. So we have of this parabola at -2. So the close value is -2 add on 0.001. When you add that up, you get a -1.999. And so we want to find the slope. So x equals -2. So y equals -2 in here and a -2 there. So x is -2. I'm plugging it in. That gives us a 4 minus 6 and works out to be negative 2. So this is the point, negative 2, negative 2. Now we're going to sub this value in. X equals negative 1.999. So that's, we're putting, again, we put a negative 2 in. Now we're going to put a negative 9, negative 1.99 squared. Add on 3 times negative 1 point. There it is. And you take your calculator and plug this in correctly, and you will come out with a negative 2.000999. Pause your calculator and work your calculator out to see if you get this value. So this point is negative 1.999, comma, negative 2. And for me, I write it down, because if I don't, I get mixed up. So the instantaneous rate of change is the slope, but it's the slope of the tangent. So that slope is y2, negative 2.000999, subtract y1, which is negative 2, and it's x2, negative 1.999, subtract negative 2. So these are double negatives is positive. So when you work that out, you'll get, add these up, you'll get a negative 0.000999. If you add these up, you get 0.001. And when you divide 3 decimal places, you'll get a negative 0.999. So we're very, very close at 3 decimal places. So we get, looks like we're getting approximately a negative 1. So at the instantaneous rate of change at when x is negative 2, which is at the point negative 2, negative 2, the slope of the tangent is going to be approximately negative 1. Okay, let's continue. More examples. And hopefully you can see the pattern I'm using. So let's find the instantaneous rate of change at 1. This is a cubic. So the closed value is 1. Whoops. It's 1. Add on decimal 001. So that value is 1.001. So let's look at the value of y. So we have x is 1. So that's 1 being cubed. So y is 1. So that's the point 1, comma 1. Now we're going to look at this value. X equals 1.001. So that's 1.001 being cubed. And when you cube that value, you got to use your calculator. You get 0.03003.001. So this point is 1.001, and the y value is 0.03003.001. So the slope, the instantaneous rate of change at 1 is the slope of the tangent at 1. So that slope, this is y2, 1.003.003.001 minus y1, which is 1, and x2 is 1.001, subtract 1, which is x1, and when we subtract 1 from this, we get 0.03003.001, subtract here, decimal 001, and when we divide 3 decimal places, so we move it, so we get 3.003.001. So the instantaneous rate of change at 1 is approximately a 3. Approximately, because we're close. Again, the more decimal places we go, if we went decimal 0.0001, we would get it closer to. Looks like you're getting close to 3. If we went decimal 0.00001, we would get even closer to 3. So the instantaneous rate of change at 1 is approximately 3. So you can see how we work these out. But notice I work it out for the value of 1 and for the value close to 1. I work them out separately, and then I can see my two ordered pairs, and I put it in the slope formula. Again, the instantaneous rate of change is the slope of the tangent. The average rate of change is the slope of the secant between 2 points, but the instantaneous is at 1 point, slope of the tangent. The instantaneous rate of change at a value of x is the slope of the tangent, or the slope of the curve at that value of x. I keep repeating this. Now let's do one more. What about we want to find the instantaneous rate of change for this? Again, this is the parabola. Remember, this parabola is y equals ax squared plus bx plus c. When it's in this form, we have a parabola. So at x, what's the value close? So it's 2 add on decimal 0.001, which is 2.001. So let's find the slope. So at 2, so we have to plug sub 2 in the x. So it's a 2 squared plus 4, 2 plus 6. We square, we get 4. The negative of that, negative 4. 4 times 2 is 8, plus 6. And that's a 4 plus 6 is 10. So this point is 2, 10. Now we take x is close to it, 3 decimal places. So we sub that in. So we get negative 2.001 squared, 4 times 2.001 plus 6. Again, instead of working these out individually, I plug them in my calculator, and when I put it in my calculator and work this out, I get a 9.99999. That's what my calculator gives me when I work that out. Again, plug all that in. Now I can put this in the calculator. The negative off a bracket around the 2 squared plus 4 bracket is multiplication plus 6, you will get 10. So this point is 2.001, comma, 9 decimal, and you got 9 nines after the decimal. So again, we want to find the instantaneous rate of change for this function, so we do the slope. The slope is at a point. The instantaneous rate of change at 2 is at the point 2, 10. So if you graph this function, a parabola, and you plot it to point 2, 10, so that would be where this tangent is going to be. So the slope, instantaneous rate of change, is the slope of the tangent, and we work it out. So it's 9.9999999 minus 10, 2.001 minus 2. So that gives us a negative 0.000001 over decimal 0.001. So that gives us a negative 0.001. Use your calculator. So notice this is close to 0. So that's approximately 0. So the instantaneous rate of change here is a 0. And if the instantaneous rate of change is the slope of the tangent, and if the slope of the tangent is 0, that means that this point, 210, must be, if you think about it, 2 comma 10 is here. That because this negative is going down like this, that means that this point 210 must be the vertex. And so if we take this parabola, y equals negative x squared plus 4x plus 6, and the x coordinate of the parabola, x equals negative b over 2a. That a is negative 1, b is 4, c is 6. So it is negative of the 4 over 2 times negative 1. So that's negative 4 over negative 2. So the vertex is at the x value of 2. This is the x value of 2. And that vertex is right there. So if the vertex is here, the tangent is a horizontal line. And the horizontal line has a slope of 0. So this value of x, which is the point 210, must be the vertex of this parabola. And we worked it out by getting a value close to it. And the slope of this tangent is 0. So that's the tangent, and that's the vertex. The instantaneous rate of change is the slope of the tangent at that point. Hopefully we explained how you find the instantaneous rate of change by getting a point close to the one that's given. And again, if you like my video, click the like button, click the subscribe button, visit my math website, www.mathfullyexplained.com, to find more information about me, my video, and the content. That's the content that's on my YouTube channel called Math Fully Explained, just one word. Thank you for viewing my video. Hope the video helped you. Bye-bye.